Question number 10, GATE 2004, 2 marks question. So for the product, the forecast and actual sales for December were 2002. So December 2002. So actual sales and forecast values. He has given forecast and actual sales. So forecast is 25 and actual sales is 20. If the exponential smoothing constant is, so if alpha is 0.2, then the forecast for January 2003 will be, we need to calculate the forecast for January 2003. So forecast for Jan 2003 is equal to F Jan. So F Jan is equal to F December plus alpha into D December minus F December. Substitute the values by after substituting alpha equal to 0.2. So F Jan equal to F December is forecast for December is 25 plus 0.2 into D December is 20 minus 25. 25 plus 0.2 into minus 5. 5 2 are 10. So 25 minus 1. 24. F Jan equal to 24. Answer is C. Simple formula only, no need to make it complex. Next question. 14. Question number 10, GATE 2003, 2 marks question. The sales of cycles in shop in 4 consecutive months are given as, okay, the exponential smoothing average method with the smoothing factor is used in forecasting. The expected number of sales in the next month is. Here we need to follow little bit different approach. So the sales of cycles in a shop in 4 consecutive months. Suppose for example if you take Jan, February, March, sales of month, this is month, Jan, Feb, he has not given Jan, February, but we are taking first consecutive 4 months means Jan, February, March, April. So 70, 68, 82, 95. Exponentially smoothing average method with a smoothing factor alpha equal to 0.4. The expected number of sales in the next month. So what is the sales in next month is April, May. Sales in May equal to S5. Sorry, S5. S5 equal to alpha into S5 alpha S4 plus alpha into 1 minus alpha S3 plus alpha into 1 minus alpha whole square S2 plus alpha into 1 minus alpha whole cube S1. Substituting the values S5 equal to 0.4 into 95 plus 0.4 1 minus alpha is 0.6 into S3 is 82 plus 0.4 into 1 minus alpha is 0.6 whole square into 68 plus 0.4 into 0.6 whole cube into 70. So S5 equal to 73.52. Answer is B. Question number 19. The question is, when using simple moving average to forecast demand, one would, when using simple moving average to forecast demand, one would, options are, give equal weight to all demand data. In simple moving average, as we have discussed that we give equal weight to all observations. But in weighted moving average, we give more weight to recent values. So option B has given is assign more weight to recent demand data. This is not simple moving, this is weighted moving average. C is include new demand data in the average without discarding the earlier data. Include new demand data in the average. This is 3 period, 4 period moving average. Include new demand data in the average after discarding some of the earlier demand data. This is also 3 period, 4 period moving average. So option which satisfies this one is give equal weight to all demand data. One would give equal weight to all demand data. So answer is A. So these are the questions which they asked in exponential smoothing alone. So many times they asked questions. So this is one of the important area. So in this forecasting, another one is regression. Regression also is used for forecasting. So regression is a method by which we estimate the relationship between independent variable and dependent variable. It is a method by which we estimate the relationship between a dependent variable and an independent variable. So we know about the correlation. Correlation is the linear relationship between the two variables. It explains whether it is positively correlated or negatively correlated. So linear regression also one of the correlation method, but it is used for forecasting. So to understand the relation between two variables, so draw scatter plot. So scatter plot helps to understand the relation between dependent and independent variable. So scatter plot is one. How to draw scatter plot is just like xy axis. So one variable on x axis, so one variable on y axis. So draw these variables. So if the each value, each observation, suppose x and y values constitutes each was observation. So if they are all forming like in the range, then this is the regression line, the line which passing through the points. So least square method. So the line is to be fitted such that the sum of the squares of the deviations from the every point and the line is minimum. The line is fitted such that the sum of the squares of the deviations. What is sum of the squares of the deviations is nothing but error. Squares of deviation from every point and line is minimum. So sigma di whole square minimum. So that is a deviation. Di means where di equal to deviation from actual values. So suppose for example y equal to a plus bx, one simple line which is passing through origin, which is passing from a constant value. For this, first you have to find normal equation sigma y equal to na plus b sigma x. N is nothing but number of observations which we are using. So multiply the x with x on both sides. So then again apply that normal equation sigma xy equal to a sigma x plus b sigma x square. From these two equations we get the value of a and b and substitute the values of a and b in the equation y. So finally we will get the predicted equation yc equal to a plus bx. So to calculate the error in forecast, we need to use difference between the actual value and predicted value. Error in forecast SYX, standard error in of y on x, sigma y minus yc or yi whole square by n minus 2, where is the number of observations, n is the number of observations. Error is a standard deviation of the forecasted value from the actual values. Suppose for example, if YL is this one forecasted values and actual values are ranging from upper limit and lower limit. So upper center line values, these are center line or some lower center line. So center line is a regression line, L equal to A plus Bx. Upper center line equal to y c plus z sxy, standard error of y on x. Lower center line equal to yc minus z syx. Z is a number dependent on the normal distribution curve. Number, it depends on the normal distribution curve. For 95% confidence interval, the value of Z is 2. So the Z value varies from confidence interval level as varies. Generally we take 95% confidence interval. So total variance in forecast equal to expected variance plus unexpected variance. So if you draw the diagram, so x, y, this is a yc which is the forecasted value, and so this part is called yc minus y whole square, explained variance. This part is unexplained variance, y minus yc whole square. So total variance is y minus yc, y bar is whole square, sorry, y minus y bar. Y bar is the average value, whole square equal to yc minus y whole square plus y minus yc whole square. Here y is the actual value, y bar is the average value, yc is the forecasted value. So x and y variables are, to choose values correct or not. So from this correlation coefficient, R equal to explained variance, expected or explained variance by total variance. that's equal to yc minus y whole square divided by y minus y bar whole square. So correlation is, if it is positive, then numerator will be more. As increases, numerator increases. Explained variance increases, correlation is more. There is another measure which represents correlation line, regression, mean square error is one thing. So if you have any seasonality effect of seasonality is nullified by seasonal adjusted forecast. Equal to seasonal index into trend forecasting. This is about regression forecasting. So we get problems mostly in exponential smoothing. In regression also, one problem they asked in 2000 exactly, 2 marks question. Question number 23. ME 2000 2 marks question. In a time series forecasting model, the demand for 5 time periods was 10, 13, 15, 18 and 22. A linear regression fit resulted in an equation f equal to 6.9 plus 2.9 t, where f is the forecast for period t. Sum of absolute deviations for 5 data is. He has given the time series forecast of the demand for time periods. So time period t and demand d. 1, 2, 3, 4, 5. So demand is 10, 13, 15, 18, 22. So he has given an equation, forecast equation, f equal to linear equation 6.9 plus 2.9 t. So substitute the t value, you will get the forecasted value here. So after substituting that value, the forecasted value you will get is f equal to 1 if t is 1 9.8, t equal to 2 12.7, t equal to 3 15.6, 18.5, 21.4. So this deviation, subtract demand minus or forecast minus deviation, absolute deviation. The sum of the absolute deviation. If you calculate the absolute deviation, so the value is 0 0.2, 0 0.3, 0 0.4, 0 0.5, 0 0.6. The sum of the absolute deviations is sum of di minus fi sigma I equal to 1 to 5 is equal to 2.3. So out of the options, A is satisfying.